Okay.
Hello everyone. So today, myself, Philip,
I'm Susanna. Crystal.
I'm Cindy.
are going to be presenting our project for science. So, before we begin, I'd like to explain the certain criteria that we're going to want to be met. The first is that we're going to use a silent thumb treatment. Idea. So, put your silent thumb up if you understand the question, or if you're ready to answer. You put it in the middle if you're not sure, and you put it down if you don't know what the answer is. So. The second is to listen to each other's ideas and be ready to give an explanation. So, listen. Explain. Does anyone have any questions?
No.
No, we're good.
Perfect. So, does anyone know what matter is? Or has anyone heard of the term matter? Would you like to explain what it is?
Matter in science is something that exists.
Something that exists.
Yeah.
Okay. Does anyone have something to add on to that? Yes?
I think it's the stuff that stuff is made out of.
Stuff that stuff is made out of. Anyone else? So, like you said, and like both of you said, matter makes up everything that we know. Matter makes up this table, matter makes up the water you have in that bottle, and matter makes up even the floor. So, today we're going to be focusing on matter. And we're going to be talking about matter by using our senses. Does anyone know what our 5 senses are? Yes.
The sense of smell, the sense of touch, the sense of the sights, the taste. Sorry.
Taste.
I said feel. Hear.
Yeah.
Feel.
Well, you have feel twice. Touch is
sorry.
feel, so that would be see.
See. That's right. See.
Oh, see.
Smell, touch, taste, see, hear.
And here.
And here.
Way to go.
Yay!
Perfect.
At least I learned something at this.
So, we're going to be asking all of you to work together in teams when answering certain topics. Alright? So, I'm going to ask my first question. Was there ever a time where you smelt something and knew what it was? Yes?
Javix.
Javix? Yes?
Food. Any
Food.
kind of food.
Ken, do you have any food in particular?
I don't know. Steak. Fries, actually, fries.
Fries. Anyone else? Yes?
My wife, I mean, lemon. I just said
So-
smell, right?
Yes, smell. Did anyone smell something this morning when they woke up? Yes.
I smelled coffee.
Coffee. Yes. Eggs? Yourself?
No, I'm out.
Firewood outside.
Firewood outside.
Someone was burning firewood.
That's a very distinct smell. Does that bring back any memories when you smell that? No?
I don't know.
Okay.
Not really.
Now, certain smells do trigger certain memories, and that's one thing we're going to be focusing on today. So, does anyone smell anything different in the room right now? Yes?
Marker.
Marker. Anything else?
Wow,
Actually, small macro, yeah.
nice. The cleaning liquid
The cleaning
upstairs
liquid
in the pail.
upstairs.
Yeah.
Yes?
Kind of smelled like vinegar.
Smells like vinegar. Well, do you see that cup right there?
I do.
Yes, that's vinegar.
Thought it was
And-
water.
Oh God, nobody drank.
So, and right in here. Oh wait, where'd the other cup go?
It's over there.
Someone drank
Oh.
it?
Okay. We have
For later.
bleach.
Mm.
Oh,
Hope no one drinks that.
oh, we don't. We'll handle that later. We could just take that part out. Now, as you can see, the vinegar does look like water. And if I had not told you it's vinegar, would have you have thought it was water? Or would have you have not questioned it?
No, because of the smell.
Okay. You would have eventually smelt it. Would have been in the air, right?
That's right.
Perfect. So, for today's experiment, we're going to be asking, how can we smell things from a distance? So like you said before, you smelled fries, right? How did you smell it, and where were you in your house? Or when you smelled firewood, you were in your house, and you,
As I was opening the front door.
as you were opening the front
Yeah.
door, you smelt it.
Mm-hmm.
So that's what we're really talking about, how things smell from not farther away. Now, can anyone tell me why they know it's vinegar? If I hadn't said it was vinegar.
Because vinegar has a distinct smell.
Yes.
The chemical makeup of vinegar has a distinct smell. And
Yes.
only vinegar smells like vinegar.
Right.
It's
So,
Sticker for you.
does vinegar smell like anything else?
No.
Yeah.
Pickle.
Pickles.
it's made by vinegar. It's made by vinegar.
Smells like vinegar.
And does anyone think the same thing as he does, that pickles smell like vinegar?
Yeah.
Yes.
Yeah.
Does anyone say otherwise, that, oh, maybe it could smell like something else? All right. From where do you smell the vinegar? If you smell it from this far, do you think it will smell stronger if I brought it closer? Or do you think over time it'll smell the same thing?
No. I think it'll smell stronger when you bring it closer.
All right. Now,
Sticker 42.
do you think the smell of vinegar can go from here to the whole house eventually,
Depending
It can,
on
depending on the quantity. Like,
depending on the quantity?
also what happens if you contain the vinegar in the cup. No, you spill that vinegar on the
Mhm.
carpet.
yes. Yeah.
Okay.
Don't do it, please.
So thank you, and I'd like to bring my friend Crystal up.
Okay.
Should we pause the video?
No. Come on. Here I have okay, I really like that you guys are using your silent thumbs, you're listening, and you're explaining your answers. So here I have a different substance in a jar. Can anyone smell what it is? Can you smell?
Nope.
No smell.
No, no smell?
No.
Okay. So if I take the lid off the jar, will you be able to smell what it is? So if you can smell it, you can just put up your silent thumb.
Eggs.
So why do you think it made a difference whether the cover was on or off of the jar?
You had covered it so there was no vapor or smell evaporating coming out from it. And the minute you open it up, you're exposing it to the air, and the matter is exposed to the
Okay.
air.
So you said that there was vapor coming out. What did you mean by
The
that?
smell, the
So this-
actual smell, the chemical smell of
Coming up?
the Javix
Okay.
is exposed.
So it's being exposed. Does anyone else have any different ideas as to why something smells like something?
Well, I also noticed you wafted it with the paper, so you kind of blew some of the smell away from the jar and towards us.
Okay, so I was blowing. What was I blowing?
Well, you're using the paper to create wind.
So I was creating wind.
The particles, the smell particles were mixing with air particles. So we were smelling it.
Okay, so by particles, what do you mean by particles? Is it particles of vinegar going up our noses?
Vapor, vinegar vapor.
Vinegar vapor.
Yes.
Okay. So you said that it was moving. So why could some people smell it before others?
Because of their look. Because of their look. Oh, sorry, you go ahead. So go ahead.
Because they were closer to the smell, to the jar.
So they were closer. So it took longer for people farther away.
Yeah.
So do you want to explain that further?
Well, the closer you are, the stronger the smell you smell.
Okay, but eventually people farther away will be able to smell it.
Because it travels. At the
Say.
beginning, you're holding the cup and then you're airing it, so they're sitting closer. They smell it first, but then it continues. The matter continues, and that's when we get it.
So
You want to become a teacher, please?
so we smell two different substances. How are they different?
Well, they're different chemicals, so they're made up of different forms of matter.
What do you mean they're made up of different forms of matter?
Well, they're composed of two different, not elements, but two different liquids that give off two different kinds of gases, which have two different smells.
So do you think that those smells get to your nose in the same way?
No, because one is abrasive and one
Okay.
isn't. The Javix has a lot of chemicals that are not good for your sense of smell, whereas the vinegar is not as chemically toxic as the Javix.
Okay, so the proximity and the concentration.
Mm-hmm.
Okay, so we're gonna write some of these ideas down. So we're gonna do a little recap. So
Can you put it a little bit higher, please?
a bit higher. Okay. So we started by saying that when you couldn't smell it when the cover was on, but you could smell it when the cover was off. So
The exposure of the matter.
and then some could smell it before others could.
The distance?
There's a distance. Yeah.
See, yes.
Then and you said the concentration, it also mattered whether it was what it actually was.
S-E-N.
What?
That's good.
Oh, that's good. Sorry. Continue.
And we also said that it was
That wasn't me.
traveling,
It
right?
wasn't him.
So is there anything else anyone would like to contribute about the discussion we just had? No?
Well, when it travels because it was facilitated by the air that you were making off the paper. So you were pushing the scent. So
You're
you're
guiding
yeah.
the
Okay, so does everyone agree with what's on this discussion board? You're not sure?
No, that's not. Oh, that's
Okay. So, in science, I'm going to leave this up so you guys can come back to it and keep looking. So in science, we have like what is called a model. And it's really hard sometimes because things are really, really large and some things are really, really small. So it's really hard to actually use these. So what we do is we create a model in order to explain like the phenomenon that's happening, and it just makes it a lot easier for scientists. So this is just a model is a way to recreate that phenomenon, to make it, sometimes it's tangible, sometimes it's, you know, just a drawing. So what I'm gonna have you guys do is close your eyes, and I want you to I want you to picture that there's a jar in front of, we're gonna close your eyes. I want you to picture that one of these jars in front of you today, is in front of you, and then I'm taking the lid off of the jar. So I want you to picture that you have kind of like special goggles on that allows you to see how that odor is moving from the jar into your nose. Okay. So I'm gonna hand out a little model, and what I want you to do is on this model, draw what you see through your imaginary glasses.
Do we have to keep our eyes closed?
No, you can open them now. And you can work together, you can discuss in pairs.
No.
Do we know which
Let's do some-
cup it is
Is it
that's in
nose?
front
Is
of
It
us?
can be
Or
any,
anyone?
it can be either of them.
You close your eyes and you have your magical glasses on,
have the color
imaginary
box.
glasses on. How do you see that the liquid is moving? How?
Toward my nose.
Yeah.
So that. You guys can discuss with each other
In
too.
the circle? In the circle? We just draw?
So this is your nose.
Yeah.
This is the jar.
Yeah.
This section is bigger now. This
Oh, we put it. Okay,
no,
so we
it's
put it here.
this, so in between this, what's going on? How is the smell from here going to the nose?
Understand?
Why is the air
How is it
particles going
going?
towards there?
How is it dry it? How do you
Goes
think
towards
the
the nose.
smell from
This is
this,
the
like
top.
the vinegar, is going
So
from the
it-
jar
so
to
it goes like
the
that,
dry
right?
entryway?
Yeah, it goes up.
This is the jar, this
It
is
goes
your
up.
nose. What's going on?
I
Explain
think
what
what
is
is
this?
How does it move towards there?
What?
Do it the opposite
Goes up.
then.
And use the thing to explain
Sniffing.
what things are.
I'm done.
Perfect.
Okay, I'll do this.
So what did you do for years? So it looks like it's coming out like smoke.
Yeah,
It's
that's
coming
what I
like
chose.
smoke, like a cloud.
I have a
And
more
then
scientific
more,
mind.
mostly
I'm
coming
sorry.
out my nose because
What
it's
do you
my
do?
nose.
It's the molecule.
Smells
Can
it,
you explain?
found the smell. So
It goes
automatically
up
I
and
feel
then
like
I'm sniffing
it's
it. so
coming
it
toward
goes
my
to the
nose, and then some of them is like going.
The particles are made up of
Yeah.
Basic.
Alright, and yours is
Yeah, she's
similar.
like-
Similar to his, yeah, like a smoke.
Does this go up towards here on?
No, it's just
Okay.
I'm so sorry.
And yours looks like
Whatever it goes, goes off to
Okay,
the nose.
so I'm done.
Looks like a cloud.
Explain it.
cloud.
That's easy to explain.
Okay. Oh, you draw each
Oh my
individual
gosh,
piece of
everybody's
matter.
I mean, I didn't,
I actually did the
I didn't put it up.
molecules.
I didn't put it to my nose because I thought this is small one,
Yeah,
so it's
yeah.
coming toward my nose.
okay.
Yeah, it's fine.
Okay, none of us belong in the art program, by the way. Okay.
Okay, so since everyone can understand the concept of matter and order differently, I want you to just look at your peers' drawing and give me a thumbs up if it's similar, a thumbs in the middle if it's sort of different, and a thumbs down if it's completely different.
of all together.
No, next.
No, just the
Oh, next
people
to you.
next to you.
Thumbs up, we're together.
Over
Very
there, so
similar,
we
yeah.
have some thumbs up in the middle. Few thumbs down. Okay.
Because it's different.
So
There's
I
a
want
similar-
one student to give me their model, and then I can draw. Okay.
Would you pick on?
Okay. So we have.
That's a healthy nose there.
It's an Armenian nose.
draw. But that's table.
Good job.
And we have.
Where was that? Jesus Christ. She took this one too.
Sorry about that.
Okay. So,
And that I
can you
think wrong.
explain to me what you drew in your model?
Okay. So whatever vapor, whatever smell is exposed from that cup is made up of molecules. Matter is made up of molecules.
Okay. So,
Molecules all have characters. In each character, the molecules have to get attached to each other in order for it to form a smell. And by attaching all of that together, that's what you get. So what's evaporating, you can't touch it, you can't feel it, and that
okay,
makes it
so you're
molecules.
saying that what's evaporated you can't physically
You can't touch it. No.
Okay. So you can't touch what
It's a gas, so you can't touch it.
just dying. Okay. So do you think so like you drew
Molecules.
molecules. Do you think that they're closer to the nose or closer to the jar?
The molecules have to come from the jar and get to the nose.
Okay, so you think that the molecules come from the jar to the nose?
Yeah.
So as you were saying before that, I think it was you that said that it moves around. So do you think that the molecules were closer to the nose or further?
At the beginning, they're further, and then as they migrate,
Okay.
if it's in a contained environment, it'll come to the nose. If not, it exposes itself into the air.
Okay, so you think that it's at the beginning it's stronger at the jar and then
Yeah.
it gets stronger to the nose.
Exactly. It gets weaker as it gets to the nose because it starts from a small area, so it's concentrated, and as it's exposed into a larger area of air, it gets diluted. So by the time you get it, it's not as strong as sticking your nose into the jar.
Okay, so basically the
The distance from the jar is what decides how strong the smell is.
okay, so essentially it's like strongest at the jar
That's right.
and then like slowly like
Yep.
dissipates to your nose.
Mhm.
Okay. So what do you want to call this? You want to call it like the scent, the smell?
Yeah.
Smell.
Call it my name.
Okay, so does everyone understand this model? Yes, not sure, no. Do we have any questions? No questions? Yes?
Isn't the smell supposed not to be seen, no matter what? And we're drawing that we saw it coming out?
You're not drawing you saw it coming out. You're drawing what you imagine is coming out.
Right.
With your magic goggles.
With your magic goggle.
Yeah.
Can I keep the magic goggles?
Is there anything someone would like to add to it? No? Okay, so I'm gonna have someone else's model. Anyone else wanna give me their model?
His is good.
Okay.
So different.
That makes sense.
I'm sorry if I messed
okay.
that up.
Looks like a carrot on wheels.
Okay, so can you explain what you
Okay, so first of all, I guess I'm not a very good drawer, but what I was trying to draw was the the vapor rather than the actual molecular structure of the vapor coming out of the jar. So when I put my magic goggles on, I just sort of imagined that there was the gas coming out of the jar.
Okay, so you say that the gas is coming out of the jar.
And like we talked about before, the gas disperses as it comes out of the jar. So the farther away we are from the jar, the weaker the smell is. But I was just, okay.
So the farther from the jar, the weaker the smell is.
Yeah, for us. And that's why I drew the gas narrowing down as it reached the nose, because it was traveling farther and farther away, so it was getting
Okay,
weaker
so
and
right
weaker.
here.
Yeah,
Okay, so that's where the smell like dissipates.
yeah.
All right. Anything else?
That was pretty much it.
Okay. And one more. Anyone want to share their model?
It's snowing there.
A snow globe.
Can you explain what you did?
Well, I think that I would need like 3 different ones to explain it. Because in the first one, when you don't like when the cup's in front of you and you don't have it right in your nose, there would be more particles of the air, square ones. And then the second picture would have a bit more of the smell ones coming in, and then the third one would be more smell and less air. So I don't know. I just did it in one picture, but
Okay.
as the
So
smell
you
comes
have,
out,
like, two like things inside your picture.
I would need 3 different pictures, kind of like that, but with different varieties.
Okay.
Because as the smell comes in, there's going to be less particles of air because they're taking over the particles, like the air particles.
Okay.
Or maybe 3 different bubbles, for instance, one
That's
right
yeah.
right at the beginning of the jar, one a little farther away, and one right underneath the nose.
That's
in
exactly
which
right.
case, her
Yeah. I would have needed 3 drawings.
Okay.
But
So let's say, what like, do you think that the air or the smell was stronger? And
the smell is definitely stronger above the glass.
Okay, so smell is stronger.
And as it gets further into the air, there's more air particles and less smell
Above the
particles.
glass. And what'd you say?
And as the higher you go into the air, like, I don't know, a foot up above the glass,
Mhm.
there would be more air particles than smell.
Okay, so there's more air particles like in the air.
Yeah.
That makes sense.
That makes it as further it travels.
Sorry?
As further it travels, it
Yeah.
yeah.
Yeah. So it needs to travel to take over the...
And you think that both the air and the smell travels?
Yes.
Okay. Some similarities and some differences, because we can see that all models are not exactly the same. So, let's see. So give me a thumbs up if you know any of the similarities within all 3 models.
two of us did particles, kind of.
Okay, so both
More
had
molecules,
particles.
Mm-hmm. All of us started it from the jar, dissipating into the air.
Okay.
We all agreed
So-
on that.
So you all agree that the scent started from the jar and then went to the nose. Scent came. And that the smell dissipated.
Mm-hmm.
Okay. As it
Traveled.
traveled, towards the nose. Any other similarities?
I was going to say all three of us don't know how to draw.
Okay, so we're done for the similarities? Yes? No? Okay, so now we're going to do the differences. What are some differences between the three? Yes.
Well, my drawing represented the actual vapor, I guess, and their drawings represented the molecules or the particles.
Okay. So we had different ideas, let me see, of how to characterize the particles?
Yeah, sure.
Or division.
Or
Yeah. We visualized it differently.
just different representations
So-
of the
okay.
same model. Mine was a little less scientific.
Yeah.
So what else is different?
The model number 2 was the only actual one that showed the dissipation as it approached the nose, right?
Okay.
Was that your intent?
Yeah.
When the triangle, yeah. So model number 2 is the only one. We just managed to get the molecules and the particles.
So
He
model
actually,
2 is the only model that shows dissipation.
Mhm.
Okay, and what's maybe one last difference?
You can mention what he said, scientific. We based it more on scientific. It's true. We based it more on scientific,
one
and
and
you
that-
based
this
it.
one and that
Yeah,
one.
model 1 and 3 were more scientific
It
based.
was more
Model
general knowledge.
That's right.
So model.
General
More
understanding.
arts oriented.
So model
More arts oriented.
1 and 3. Let's use scientific terms.
Yeah,
I would
more
say.
scientific.
Yeah.
Anything else anyone would like to add? Yes? Not sure. No. Okay. So when looking at all three of these models, we have similarities and differences, but what we'd like to focus on is more the differences. Because in order to understand, you need to understand what other people understood besides your own model. So we have everyone represented differently. Over here we have one type of molecule. Here we have just a scent, and here we have both the air and the smell as two different particles. So, I think that they're all great models. You all understood that most of them understood that the smell is closer to the smell, you all believe that the smell was stronger near the jar and dissipated towards your nose.
Mhm.
Okay. Okay, so good job, everybody, for drawing these out. And I just want to remind you guys of the silent thumb, that you're doing very well, that you're listening to everybody, and that you're explaining what you guys went through trying to draw this out. So, given the differences, the main goal for today is to understand how we smell things from distance. And we want to represent that today. And the way we're going to represent it is through our consensus model. So does anyone know what a consensus model is? Can you see the thumbs? Yes? You're not sure? Okay, what do you think?
I thought I knew, but then I changed my answer.
So
But
what
I think
do you
it's
think it is?
just a model that we can all agree on in a consensus.
Okay, can anyone add on to that?
It's a proven model. It's a scientifically based model of it. So someone has, a whole bunch of people have consented that this is how that is represented. So
Okay.
it becomes a consensus.
You use the word proven. So
Scientifically
in science, we just want to remind you that we don't use the word proof. It's evidence, because nothing is actually proved. It's evidence that you use through the experience. So through your experience, this is what you guys came with, right? So can anyone tell me which model from 1, 2, 3 is the least detailed? You're laughing. Yes?
2.
Okay, so model number 2 is less detailed. And can anyone tell me which one is the most detailed? Yes?
The number 3, because
Number 3?
yeah,
Why?
number 3 actually shows you the breakdown of the air and the smell. So when it starts, it gets exposed, and when it finally gets to where it's going, if we actually had the 3 bubbles, they would have 3 different explanations, so that would make it much more detailed.
Very good. So can anyone repeat what she said?
Why you didn't hear?
I want to know if everyone
Okay.
understood. Can anyone repeat what she said? Not repeat, but explain what she said. Yes.
It just shows that they're two different things. That the air is its own particle and the smell is its own particle. So it's in 2 separate categories so that you can really see with your eye
Okay.
where the smell is traveling.
Okay, so before working on model 3, can we in some way from model 2 get a more detailed look of what's happening during these waves? Think about it. It's the least detailed one, and I want to get to, let's say, a more detailed version. Yes.
Maybe if you add different colors to it, like the stronger the smell, the brighter the color, and then you can go like fade the
Okay,
color.
so here we'll do strong smell, brighter color. But I'm talking about the way you represented it. So instead of representing it with the waves that he did,
Okay.
a little more detailed. How could we add more details to it? Yes.
Maybe you could represent it by including more molecules, both of the air and the chemical particles. So
Okay.
with the chemical particles or molecules, there would be more of a concentration of them around the cup. And then they would dissipate as they reach the nose, and they would be more mixed with the air particles as they reach the nose.
Okay, so we just say that we could use model 3 as a basis
Sure.
of what we're learning today. Does everyone agree? Or no? They would like to use another model. Everyone agrees. Okay, so here we are going to draw. I don't know how to draw.
No,
No, with that marker.
Oh, thanks. Thank you. Okay, so that's the nose. And then we have this. Like this. And then your jar is here. Right? And the lid's open. So, judging by model 3, who understands that the squares are air? Okay, who understands that the O's are the smell?
The one that went to school and learned.
Okay, I'm just making sure. Okay, so you guys, you said something really good. You said you needed 3 drawings to
Yeah.
represent what happened. So what would you do in your first drawing?
The first drawing that would be closer to the jar would have more of the circles and less.
Okay, so this is our jar, right? Our circles are the smell.
Yes. You can split. Yeah, split maybe the.
Yeah.
Okay,
I should have done that. Split it in 3.
so this would be it. Would you still have any air in there?
Oh,
Yeah?
Because there's always air.
Okay, so you did it with squares, so let's do a few airs, right?
Yeah.
Is that okay, or should I
Mhm.
add more?
That's good.
Okay, so this would be your first one, and you said you want to split it up, right? Okay, so what would be your second drawing?
Maybe half and half.
All
say.
equal parts in the middle. Okay, so square, square. Sorry for the sizing. Okay, so you have 1, 2, 3, 4, 5, 6, 7. So you have 1, 2, 3, 4, 5, 6, 7, let's say, right?
Yeah.
And what would your third one be?
Mostly air.
Mostly air. Square, square.
And they
Yeah.
do get like bigger and more spaced apart, so it's good that you
Okay. Okay. So you like the bigger sizes. And do I put any circles in there or
Yes.
Yeah.
no? Just a few or the same?
What you did in the first, yeah, like 5 circles. Or
Okay, so
4
we're doing-
4 circles.
That's it.
Because you still have to smell it, right?
Okay, perfect. So, you did 3 different drawings, but you understand that in that split second, does everyone understand that in that split second that we showed you what you smelled, that all 3 of these happened? Or does you don't understand? Does everyone have that experience that at first you couldn't smell because it was in the jar, and then when she aerated, you guys could smell because it was close, and then you guys could smell because it reached you? Does everyone agree?
But in the vinegar case, we smell it from the distance also, without airing it or without coming toward us. So
Okay. But do you still agree that the jar had more vinegar
Yes.
smell when it was closer to you?
Mhm.
Right? Okay. So could I just erase then?
Yeah.
This? Because technically, if you're telling me you experienced all 3 of the drawings at the same instant in the split minute or 2 that we showed you what it was, then it means it happened at the same time and not on separate occasions. Right? So let's erase the splitting here, and I'll just add a few more. So you have a square here, and then you said it's getting less and less, and it's getting even, and then like this. So does everyone understand this model? Can anyone explain it to me one last time?
yeah, it starts with stronger because
Explain to you with the symbols.
what do you mean similar?
Well, explain what's getting stronger.
Oh, what's getting stronger? The smell starts stronger, fewer air. Once
When it comes with the air, it comes.
Wait, let's wait for your turn.
once mixes
What
through
up?
the air and travels the distance,
Yes.
and the more air, the smell starts going down
Okay.
until it reaches your nose. You still can smell it, but not as closer to the jar from your distance.
What would happen if I leave, like, do you smell it now?
No.
So what do you understand from it?
It
Yes.
does. Okay, go ahead. Go ahead. No, go ahead.
Okay, so when the jar is covered,
Yes,
the smell is covered.
yes.
When you uncover it, you're exposing the smell to the air. When the jar is covered, the air is what's out there. The minute you uncover it, you're exposing the smell into the air. So it starts strong until the air, at the beginning, the smell overtakes the air. And then after a split second, the air manages to camouflage the smell again.
Why do you think that is?
Because of the volume of the amount of air to the volume coming out of the cup. We're busy.
Of the smell. Okay, can anyone explain to me what that meant? The volume of air compared to the volume of smell.
You're up.
She said the volume of air gets stronger. That's why it's still open, but you guys can't smell it. So let's see if everyone understands why. Yes.
Just when the volume of air is larger away from it because there are less smell particles, more air particles.
Okay, good. So now one last thing. Here, in our general representation, we see the smell going there, right? To our nose. What is this? Which one? What is this? Is
That's
this-
just the smell sort of dissipating in every direction.
Oh,
It doesn't go
okay.
in one
So
direction.
does everyone understand what this is? Still the smell coming out of the jar, right?
Mhm.
This part here.
Mhm.
This is still the smell coming out, but it's going elsewhere. So what does that mean for smell? If I open the jar
is it going straight to your nose?
No,
Or where is it going?
going to the air.
Everywhere?
Sure, everywhere.
It's going everywhere. So you're telling me that if I open this jar, it's not only going to the nose, but it's moving everywhere.
Sure.
How can I represent that here? I represented the two smells, but if someone looks at it right now, they're just gonna see it, smell and particles. I wanna know how you can mark and explain to me how it's moving around.
So, go ahead.
Go ahead.
No, go
No,
ahead.
you go.
So basically, you put the smell,
Mhm.
equal smell on the lower part, and then going upward, you bring it less and less and add more air to it.
That works, but then again, I'm gonna still have a representation, and if I show it to anybody else, they might think that it's just mainly concentrated in this area, this small area between your nose. So how can you represent it?
Put arrows going up and across.
Oh, so can anyone tell me what she said?
Yeah, she said arrows up and down.
Put
That
arrows
means it's
up
moving
and down.
around.
So do I just put arrows up?
Up and side and
So random arrows.
Up,
so
down,
this,
Yeah.
diagonal, everywhere.
down, like this.
Yeah.
All over, right? For the air too. Okay. So you guys now understand.
Little bit.
What don't you understand?
But because if there is wind,
Mm-hmm.
okay, he makes
It
more arrows going up or beside
So
the
it
wind.
depends.
It
what
depends
you're
where the
smelling and
wind,
what.
yeah.
So you're telling me when Crystal aerated it,
Well, yeah,
you smelt it more
more
before
than,
them.
sure.
Okay, so does everyone understand that smell is not concentrated? It's concentrated, but it depends the circumstance that it's in. Okay, so one last time. What's the consensus model?
It changes according to the
What's
situation.
consensus model?
What's that? Ah, okay.
Yeah.
It's a scientifically proven,
Not
not
proven.
proven evidence
Okay,
based
and
theory.
scientific based theory. Okay, and so smell moves around. So the main question today was how do we smell things at a distance? Can anyone answer?
Because it moves around.
Smell moves around, air moves around.
And then they move together, and then it's always in the air,
Okay.
but eventually will go lesser in power.
Okay, does anyone want to add on to it, or is everyone okay with that answer? Everyone's okay? Okay, so I think my
Say
team
okay.
and I would
I'm
like
good,
to
I'm
thank
good.
you for participating today, and I hope you guys learned something. So, good job.
Thank you guys.
I don't want